Hello everyone, welcome back to another video for the series. I'm Inokyu and today I brought a problem from KMO. Um, the problem is find the minimum of a real number m that satisfies the following inequality for positive real numbers where a sub 100 is equal to a sub 1 and a sub 101 equals a sub 2. At first, I thought there was an error with the problem because, m is a real number, not integers is a real number. And this inequality is strict. So I was like, can we have a minimum value of a real number here? Because if it is strict, that makes sense. But if it is not strict, then it makes sense. But this is a strict inequality. So I wondered if there was an error with the problem, but it turned out that there is no problem with this. And yes, because there is no problem with the problem, I was trying to find the limit of the sum because limit of this series, because if I find it, then I can also find m, because we cannot reach the value if a function is defined something like this. So I was looking for something like this one. I couldn't do it, so I had to look up the solution. Unfortunately, KMO, the Korean Mathematical Society, KMS, they don't share their official solution unless you buy them. So I had to search in the internet, and luckily there was one solution in the internet and I really loved it, so I decided to share it today. So it starts like this. So notice that a sub k plus 1, I'm quite lazy to write them, I'll just write it like this. A sub k plus 1, a sub k plus a sub k plus 1 plus a sub k plus 2 plus a sub k plus 2 over a sub k plus 1, a sub k plus 2 plus a sub k plus 3 is obviously less than, because a sub I is a positive real number, a sub k plus 1 over a sub k plus 1 plus a sub k plus 2 plus a sub k plus 2 over a sub k plus 1 plus a sub k plus 2. And this is quite obvious because a sub k is greater than 0, a sub k plus 3 is also greater than 0. And notice that this is equal to 1. So we have 99 terms right now. If we could group them like this, we will have 98 divided by 2 is 49. So we have this whole thing less than 49. But unfortunately, we cannot do this because we have one term left over. So we either need to group them by 3, or we have to group 1 by 3 and everything else with 2. That way we can find the range, or like an upper bound for our series right here. So let's prove that there exists. Let's prove our lemma. Our lemma is there exists a k such that a sub k plus 1 over a sub k plus a sub k plus 1 plus a sub k plus 2 plus a sub k plus 2 over a sub k plus 2, 3, no, 1, it starts with 1, plus a sub k plus 3 over a sub k plus 2, 3, and 4, sorry, is less than or equal to 1. And here is our proof. So in order to prove this, the reason why we have it less than or equal to 1 is because if we group them 2 and then 1 and 3, where we have 3 terms, then we can say this is less than 49. and that creates an upper bound for the series. So that's why we wrote our lemma like this. So in order to show this, it suffices to prove that I don't want to be too formal right now because I'm quite lazy to write them. Plus 3, 2, 3, 4. I think everyone can understand what I'm saying right now if I do this. I think that would be much better. So from now on, I'm quite, because I'm not going to like write my solution like in a really formal way. It's not formal proof because there is like different formal proof, but not like the solution that the graders want. I'm just gonna be informal here. 0 represents a sub k, this represents a sub k plus 1, and obviously this represents a sub k plus 2. I'm just, yes, 2, 3, yay, this is much better, much better, I love it. It suffices to prove that this is true, because this is equal to 1. Because this is equal to 1. And notice that they cancel out. Therefore, it suffices to prove, yes, it suffices to prove that 1 is, 0 is greater than or equal to 3. And 4 is greater than or equal to 1. This doesn't, so this inequality doesn't tell this right away, but if this is true, then our inequality is true. So it suffices to prove that this is true. It suffices to prove that there exists k such that this is true, then this will be true, then our lemma is true. So let's prove that there exists a k such that they are both true. A sub k plus 1, and it's quite simple from here. It's just induction, so not induction, sorry, we can prove it by contradiction. So for the sake of contradiction, let's say that this is always true, meaning there's no k such that this is true. If this is always true, then there's no k such that this is true. However, if we disprove that for all k, because it's 4, we should be able to define it. We have it until 102, right? No, 101. So 97 would be good, I think. Yes. So if we disprove this, that means there exists a k such that this is not true. But I think because from 98, 99, this is not defined, and we don't need to talk about that. It's not defined. So this shows every case from a sub 1 to a sub 101. If we disprove that this is true, then we just disprove that there exists a case from a sub I, from where it's defined, such that this is not true, meaning this is true, there exists a case such that this is true, this, and they are all true. Let's prove that. Starting with k equals 1, it tells that this is true, a sub 5, 6, until 97. A sub 7 less than a sub 1. Well, but notice that we don't have to take a look at the next one because we already disproved it from here. So this must be true for all k here. But notice that, oh no, sorry, never mind. Uh, let's use this one. So a sub 5 is less than a sub 2, a sub 6, a sub 3, a sub 7, a sub 4, so on until we get a sub 90, a sub 1, a sub 2, a sub 2, a sub 90, 90. What happens when we substitute 96? A sub 99, a sub 96, a sub 1, a sub 97, 98, a sub 2. So this is always true. Oh, this one. This cannot be true. This cannot be true. So our statement, this one is false because of a case that doesn't work. Yeah. So because of this case, it's not true. We don't have to look at them. Well, I'm just gonna write it. Yes. So there is this. So this lemma is true, meaning our summation k equals 1 to 99, 0 plus 1 plus 2, 1 is always less than 49. Now there is a general rule of thumb. It's writing them alternatingly. Equals. So notice that if we let a sub 3 equals a sub 99 equals 1, a sub 2 equals a sub 4 equals a sub 8 equals 0. I mean, they cannot be equal to 0 because it's a positive number. But if you compute the case for this, we can actually change this to a and find the limit. So this actually gives us the limit value. So let's find out. So if we do this, we get 0, 1 plus 0 plus 1 plus the next one, a sub k plus 1, right? So 2. 0 plus 1 plus 0. 1 plus all the way until what happens when we substitute 97? 1 plus 0 plus 1 over 0. How about 98? It's 0 plus 99 is 1 plus 1 is 1 over 1. How about 99? 100 is 1, right? So 1 and 99. 99. 1 plus 1. No. Oh, it is right. Plus 0. This will continue until we have this. So we can group them. We don't know how many, we can't count how many groups there are. So 99 minus 3 divided by 2 is 96 divided by 2, which is 48. When we compute this, we get 48. So this is equal to 48 plus 0 plus 1 over 2 plus 1 over 2, which is 49. Oh, so that means let's change everything into A. Oh. If we change this to A, equals a, then a. Why don't we write it x, because we have a and that might be confusing. Wait, we have 0, 0, 0. I mean, we're not allowed to use calculus. They really hate it, but I think they allow this kind of calculus. So we are not actually allowed, we're not allowed, but I mean, we are not allowed, but we are encouraged to not use it because graders don't like it. So let's say our sum is equal to this one. If we write them like this, obviously this is true. Now notice that the limit as x approaches 0, the sum approaches 49. 49. Meaning, yeah, this is differentiable. Yeah, this is differentiable at x equals 0, right? I think so. This is differentiable at x equals 0. I haven't done my derivatives and this thing for a while, and I don't quite remember, but I think we can still compute our limit. No, this is continuous, right? Obviously, this is continuous, I think. Yes, this is continuous, and that's because this itself is continuous at x equals 0. This is just a yeah, this is continuous. We could actually graph this, and similarly, this one obviously they two are we can graph it like like this. So this is continuous at x equals 0. This is continuous. This one and this one, are they continuous? We don't have to look at this. So we just need to prove that these two are continuous. Yeah, they are continuous because it is defined at x equals 0. As it gets closer and closer to, yeah, this is they're continuous. So we could say that this is true, meaning our sum, our series right here must what is the word 수렴한다 in English? It approaches, our sum approaches number 49 if you have this kind of arrangement. But notice that our upper bound is actually also equal to 49, meaning if we graph them, it would be approaching 49 like this, if this is 0, like this. And we are talking about this specific arrangement right now. I'm not sure if it's like this or not, but I'm pretty sure it's like this. Because if it's negative number, if it's greater, so if x approaches infinity, it actually approaches what is this? How many terms do we have? It actually approaches 48 plus wait, if it approaches infinity, I'm sorry, wait, if it approaches infinity, but if it approaches infinity, 0, this becomes 1. How many 1s do we have? Wait, how many numbers do we have right now? 48 plus 1. That's 49. What? No. No. Okay, then maybe it looks like something like this. Like this. Yeah. Oh, I think this makes sense. This makes sense. I'm not sure. We have to graph them, but just by looking at it, this does make sense. Um, Therefore, m is equal to 49 because as is approaching, our series is approaching 49, m cannot be anything less than 49, but it cannot be anything greater than 49 because we already know the upper bound for the series, and that is 49. So m must be greater than or equal to 49, but it's also less than or equal to 49. Yeah. Uh, so therefore, m is equal to 49. And that is correct. So that completes our proof. And that was, I think, this problem. I really love this problem because the way that they group them is quite typical idea that I think many people consider. And also this arrangement is also quite famous. So I mean, I was not able to solve it, so I'm not the one to say it, but I really love this solution and love this problem. Good luck to everyone who is taking KMO soon. Uh, Thank you so much for watching this video, and I will come back with another very fun and interesting problem tomorrow. Thank you, and see you tomorrow. Bye.